Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about magnetic field due to a toroid. What is toroid? This is the shape of the toroid. Toroid is a circular ring on which large number of turns of the wires are closely wound like this. Okay? Circular ring on which large number of turns of the wires are closely wound. If a current flows through it, this toroid will produce a magnetic field. What about that magnetic field value? We will see. We are going to apply Ampere's circular theorem and we will find out the magnetic field. So, I am taking three cases. The first case, the point is P is here. That point P is R1 distance from the center of the toroid. Okay. If I need to apply Ampere's circular theorem, I have to consider a closed loop. So I am going to consider as a closed loop like this. This is the closed loop in a circular shape of radius R1. What is Ampere's circular theorem? Integral B dot dl is equal to mu 0 I n closed. Here, this is the Amperian loop. In this Amperian loop, what about the enclosed current? The enclosed current is 0. So, what about this value? So, integral B dot dl is equal to 0. So, what about B value? B is equal to 0. So, magnetic field at a point exterior of the toroid is 0. Clear? Next, case 2. Case 2, I am going to consider a point. Q that is inside the open space of the toroid. This point is R2 distance from the center of the toroid. Clear? So, I am going to apply Ampere's circular theorem. For applying Ampere's circular theorem, we need an Amperian loop. Here, I am going to imagine as an Amperian loop in a circular shape of radius R2. Okay. What about Ampere's circular theorem? Closed integral of B dot dl is equal to mu 0 I n closed. What about the enclosed current in this Amperian loop? Is there any current? There is no current. So I is equal to 0. This is equal to 0. So B value is to be 0. Clear? That is about case 2. Now we will see case 3. In the case 3, I am going to consider the point here, that is R. Point R is inside the toroid. Okay. So that point is R distant from the center of the toroid. Okay. Then, so we need to imagine an Amperian loop. Okay. So I am going to imagine an Amperian loop in this shape. This is the Amperian loop. Okay. Clear? What about the magnetic field produced due to this circular turns? Toroid means large number of turns like this circular turns. Here the current is flowing like this direction. So I can find out the magnetic field like this. Okay. Curl, if I curl like this, magnetic field is like this. So magnetic field is like this. Okay. Okay, this is the magnetic field direction. Magnetic field like this. This green color is Amperian loop and the blue color is the magnetic field direction. Okay, clear? So I am going to apply the Ampere circular theorem, that is integral B dot dl is equal to mu 0 I enclosed. This is the Ampere circular theorem. What is integral closed integral B dot dl? That is B dl cos theta is equal to mu 0 I enclosed. That is integral B dl is equal to what you will get here. Here dl and b are what? Tangential, because magnetic field is like this and the loop also in the same direction. So we will get b dl cos 0 we will get, that is integral b dl is equal, we will get. Okay, what about integral b dl? Integral b dl equal to b I am taking outside, integral dl. That is what about integral dl? That is equal to b into integration of dl. That means this blue color, each you add it. So what you will get? Total circumference of the circle, that is 2 pi r. That is about the integral b dot d. Next we will see what about I enclosed. Okay, so I am consider n is the total number of terms. Okay, this capital n is the total number of turns. Then through one turn I current is passed. So totally how much time? N number of turns. So total current enclosed in this loop is I into n. Okay, so now we can apply this in Ampere circular theorem, that is integral b dl is equal to what we got? B into 2 pi r, that is equal to mu 0 into n9. Okay, so b is equal to what you will get? B is equal to mu 0 I into n divided by 2 pi r. What is this n by 2 pi r? N by 2 pi r is the number of turns per unit length, where this loop length is 2 pi r. So b is equal to mu 0 n I. What about the small letter n? Small letter n is equal to capital letter N divided by 2 pi r, number of turns per unit length. So magnetic field produced by a toroid is mu 0 n. That is only inside the toroid, inside the open space magnetic field is 0, exterior of the toroid magnetic field is to be 0. Clear?